Welcome to solverfy.
Question number 91 is a separation by precipitation problem. The scenario is you have two solutions that you are going to combine together, and in the process the cation of one of the solutes in one of the solutions will combine with the anion of sodium hydroxide, and then the other solution will also contain a cation that can combine with the hydroxide that is going to be added. And we need to figure out, for the purpose of separating these two cations, which cation will combine first with the hydroxide that is being added. So if we mix these two solutions together, we of course will have 175 milliliters, and each of these concentrations will change slightly due to the volume having changed. So let's first calculate the new concentrations of each cation. Cadmium, which was at 0.25 molar, can have its new concentration calculated by taking the volume of cadmium in liters multiplied by its original concentration to get the moles of cadmium, now in the larger volume, divided by the new volume in liters, gives us 0.179 molar. The iron 3 plus concentration in the 175 milliliters can be calculated in a very similar fashion, taking 0.5 divided by 0.5 multiplied by 0.05 divided by 0.175, and we get 0.143 molar. Now we are going to add hydroxide to this solution that has cations at these two concentrations. Cadmium will combine with hydroxide to form cadmium hydroxide solid, and iron 3 plus will combine with hydroxide to form iron 3 hydroxide solid. The KSP for cadmium is equal to the cadmium hydroxide is equal to the cadmium concentration multiplied by the hydroxide concentration squared, and we can look up that value. It's 7.2 times 10 to the negative 15. We'll do the same thing for the iron 3 plus with hydroxide forming iron 3 hydroxide. KSP will be equal to the iron concentration, which we calculated up here, multiplied by the hydroxide concentration cubed, because three of them are going to react, and we look up that value, and it's 1.6 times 10 to the negative 39. So we can rearrange each of these questions, or each of these equations, in order to solve for hydroxide, knowing the cadmium concentration and the iron 3 plus concentration with the corresponding KSP values. Hydroxide will be equal to the hydroxide concentration, for which precipitation will begin at a cadmium concentration of 0.179, will be equal to the square root of KSP for cadmium 2 hydroxide divided by the cadmium concentration, and we get 2.01 times 10 to the negative 7. We'll do the same thing to solve for the hydroxide concentration that will initiate precipitation of iron 3 plus when the iron concentration is 0.143. It ends up being the cube root, just rearranging this equation, of the KSP value for iron 3 hydroxide divided by the iron 3 plus concentration that we calculated up here. And we get 2.24 times 10 to the negative 13. So it becomes obvious that iron 3 plus requires a much smaller hydroxide concentration for precipitation to begin than the cadmium 2 plus. So iron 3 plus will precipitate first. The way to separate these compounds, these cations, would be to slowly add in some hydroxide to initiate the precipitation of iron 3 plus, but keep the hydroxide concentration below 2.01 times 10 to the negative 7 in order to prevent the cadmium 2+ from precipitating.